Hello everyone, my name is Muhammet Enes Zengin. I'm an industrial engineering student at Bilkent University. Today I'm going to present my Physics 102 lab project to you, which is about electromagnetic induction. In the experiment, I investigated how the mechanical energy of a freely falling magnet can be converted into electrical energy through electromagnetic induction. My main objective was to observe this energy conversion and compare the experimentally obtained electrical energy with the theoretical gravitational potential energy. This experiment is based on Faraday's law of electromagnetic induction, which states that a changing magnetic flux induces an electromotive force in circuit. As the magnet falls through the coil, the magnetic flux changes, which induces a voltage. I also used the relationship between voltage and power in a resistor, and I calculated the total electrical energy by integrating power over time. Additionally, I compared my results with the gravitational potential energy, which depends on mass, gravity, and height. Throughout the experiment, I will be using these equations. The experimental setup will consist of a solenoid coil, a neodymium magnet, a 100 ohm resistor, and a digital oscilloscope. Here is a 400 winding coil, and here we have a 100 ohm resistor. This is my setup. As you can see, we fix the coil like this. Then we connect the coil's terminals to our resistor. We also connect the oscilloscope probes in a parallel to our resistor. Here you see an example snapshot of the magnet I dropped from a height of 10 centimeters. And if you look carefully, you can see the change on the oscilloscope. These are some time voltage graphs on the oscilloscope for each different height. This is for 10 centimeters. This is for 20 centimeters. And this is for 30. After the measurements, here are the tables. The tables show how voltage and instantaneous power change over time. They also show the energy segment in each 10 millisecond time interval. After finding these data, all that remains is to combine these energy slices to find total energy. This is a visual chart of the instantaneous power drawn separately for each height, so we can see everything more clearly here. And let's especially note that the energy totals are the sum of these small areas. Finally, in this table, we can see the total electrical energy and the efficiency rate obtained by comparing it to the initial energy. Overall, we expected that increasing drop height would result in higher induced voltage and of course greater energy. Hopefully our results confirm this trend because the energy values are increased as the height increased. However, measured electrical energy was still lower than the theoretical potential energy, indicating that the system is not fully efficient. And obviously this difference can be explained by several energy losses, including air resistance during the fall, heat dissipation in the resistor, and the fact that the magnet retains some kinetic energy after leaving the coil. Additionally, the induced current creates a magnetic effect that slightly opposes the motion, further reducing the energy converted into electricity. Thank you for listening to me.